So we're kind of working on the same thing we did last week, but it's just like a little different.
Okay.
So it's roots and end behavior is the title of the worksheet that we're working on.
Okay.
And it's the directions are for this section is solve the following polynomials, provide both real and imaginary roots.
Okay.
So then number 12 would be 12x raised to the 6th minus 32x raised to the 5th minus 25x to the 4th plus 129x cubed minus 102x squared minus 4x, sorry, plus 40.
Plus 40?
Yeah.
They want you to solve this how?
Well, they want you to plug it into your graphing calculator and then use...
Okay. Because they haven't taught you how to factor this. The only way to solve this is with a calculator. So
yeah.
Let me plug it into Wolfram Alpha. Not that this exercise is going to do you much good, but I don't know what else to do.
I can plug it in on mine as well.
Let's do that. In other words, make sure you know how to plug this into your calculator.
Okay.
While you're doing that, I'll go ahead and plug it into here. Now there's going to be one major advantage of mine. It's going to tell me what I put in case I made a mistake. Whereas yours doesn't do that. Do you have the Inspire or the TI-84?
I have the Inspire.
Okay, actually the Inspire does do that.
Oh, okay.
One of the nice things about the Inspire is that it tells you what you input.
Okay.
Okay, I got mine in correctly.
Mine shows that it has 4 roots.
Okay.
Is that what yours looks like?
I've got a root there. That's 1, 2, 3 goes down below, and then 4. And the other beauty of Wolfram Alpha is that it'll tell you your 4 roots.
Oh, okay.
Automatically. It's still working on it. In other words, it's so hard to find 4 roots, but it's still working. Normally, it gives you the zeros right away.
What is this thing called that you're using?
This is called Wolfram Alpha. It's wolframalpha.com.
Okay.
I don't know if this is that much better for you. Your Inspire, does it give you the zeros also? I don't think it does it? You have to go in there and do some sort of a trace on it?
Yeah, you do have to do it like
Mine's still working, see? So it's still calculating the zeros.
Oh, okay.
Which is kind of odd because it drew a graph. You'd think if it could draw the graph. We clearly have a 0 at -2. And then that must be some irrational 0 there. And there's a couple of them around. You know how to get this done on your Inspire?
Yeah.
Okay.
I can do that now. I'll look.
Okay. Well, there's not much else to do on this problem other than, in other words, this is not a terrifically great problem for teaching anything other than how to find the zeros. Higher degree number from a calculator.
Yeah. Well, don't we have to find, like, because what we learned today in class was that you had to find, like, the imaginary roots with synthetic division?
Well, there probably are two imaginary roots with this because x to the sixth is going to produce usually 6 roots.
Mm-hmm.
Since we can only see 4 zeros, there's probably 2 more that are imaginary. But coming up with them, if you gave me the other 4 roots, then I could come up with the remaining quadratic by dividing each of those roots. In other words, the goal in these is always to reduce it to linear factors and all linear factors. In other words, I should be able to come up with 6 linear factors here. X minus something times something, so forth and so on. And the final one is probably some quadratic which has imaginary roots. So I'm guessing that this has 4 real zeros and 2 imaginary zeros. Imaginary roots always grow, but figuring out what the imaginary root is, we have no way of doing it without the other 4 real roots.
Okay.
Ellen, let me try something. I'm getting a tremendous amount of background.
Okay.
Can I call you this same line and have you enter it on a speakerphone? Does that work for you?
Yeah.
Let me do that and see if I can't get rid of some of this background noise. Sounds like a roller coaster.
Yeah, it does.
Oh, you can hear that also. Okay. All right, let me try Google Phone. Should I call the same number I just called that I texted? Or is there a house phone that would be better?
Probably the house phone.
What number is that?
303 904 9772.
See if we can't improve things a little bit by doing that. On your go-to
There is one other caller on the call. There is one other caller on the call.
Ellen?
Yeah?
Okay, I can't tell if I'm talking through your home phone. Which one are you talking through?
I'm talking through GoToMeeting. I never really got a call through Google.
Okay, but something happened that made it better. I heard it ring, but I guess you never answered. Okay. No, let's try this one more, if you don't mind. What was that number again? 303 9
04
Uh-huh.
9049 or no 9772.
Do you hear that ringing?
Yeah.
Okay, go ahead and answer. Now we actually should have communication through either. To your Google control panel, turn off the mic. I know what's going on.
There is one other caller on the call.
Ellen?
Yeah?
Okay, you're apparently when I call on the Google phone, it's disconnecting you because I lose all audio completely.
Huh.
All right, we'll just we'll deal with this. I can deal with it.
Okay.
Let me turn my volume down a little bit. That might help a little bit. Okay. All right, what else you got? There's not a lot I can do with this problem. There's nothing to do with this problem. You could give this to a PhD in math and he wouldn't be able to factor it. These
Okay.
are enormously difficult to factor, unless they give you a few factors. In other words, if they gave me 4 factors, then I could divide each one into this polynomial, reducing it to a quadratic, and then I can factor that. But without giving you any of the factors, there's simply nothing we can do with that. I mean, you could find the zeros on your calculator, and then you use those 4 zeros to write them into each of that and come up with a quadratic and then come up with the imaginary solutions for that. But I can't imagine that that's what they want you to do. That would be a half-hour problem.
Oh, okay. Then we'll move on to the next one.
All right.
Okay, let's see. Okay, so it says, oh yeah, the directions for this one are find a polynomial equation that has integral coefficients and the given numbers as roots.
Okay.
And then it says number 8, 0, and then in parentheses it says triple root, and then -2, and then it says double root.
Okay. So what are our factors going to be?
3x, like x times x times x.
Which is x cubed.
Yeah, and then x plus 2 and x plus 2.
Which is x plus 2 squared. So
Yeah.
if we multiply those two together, we'll have the polynomial they want.
Okay.
Okay, let's expand that. What do you get?
X squared plus 4x plus 4.
Now multiply by x cubed.
X to the 5th plus 4x to the 4th plus 4x cubed.
And there's your answer.
Oh, okay.
And that has integer, they said integer coefficients, right?
Yeah.
Right, that has integer coefficients. Now, what if we would have had this? 4/3 x cubed. Well, now, in order to get integer coefficients, I got to multiply everything by 3. In other words, if that were equal to our zeros, in order to get integer coefficients, I would have to multiply everything by 3 to get this.
Mm-hmm.
And that would be the answer. But in the problem they gave you, we came up with integer coefficients on the first try. So there's nothing further that needs done.
Mm-hmm. Okay. The next one is the same one, but it has 0, I as a double root, and then -I as a double root.
Okay, so it's x times what?
X minus I squared, and then x plus I squared.
Now, we can do these normal. In other words, I could just square that, multiply the two trinomials together, That's actually a little hard. If we write it a little different way, notice that we can make the solution a little easier. See what I'm doing?
Yeah, yeah.
And now when I multiply that, the I disappears. What do you
Okay.
get when you multiply x minus I times x plus I?
X squared minus I squared.
Which is x squared plus 1. I get it in both places. See why x squared minus I squared is x squared plus 1?
Yeah.
Okay. Now the multiplication is a little easier. I can certainly multiply these two things together easier than having to deal with a trinomial. Multiply those two together, what do you get?
X to the 4th plus 2x squared plus 1.
So now when you fully multiply it out, here's the answer.
Okay.
And again, did they just say that it needed to have integer coefficients?
Yes.
Okay. Let's talk about that for just a minute. Okay.
Why
is that what they're talking about? It's not always clear. This definitely satisfies their condition. That has roots of 0, plus I, minus I. If I multiply both sides of this equation by 2, which I'm always allowed to do, I get a different function. This is not the same as this. What they do have in common is they have the same zeros. In other words, when I set this equal to 0, that's what it meant. You said the zeros were 0, plus I, and minus I.
Okay.
Okay? Had they said, give me a polynomial whose leading coefficient is 2, then this wouldn't have been the right answer. That has a leading coefficient of 1. But I could have come up with it by merely multiplying the entire polynomial by 2.
Okay.
So this polynomial here has the same zeros as this one. But it's not the same function. It's kind of like the difference between y equal x squared and y equal 2x squared. They have the same zeros, but they are different functions.
Okay.
Or
Yeah,
y equal 4x squared. Same zeros, different function.
Okay.
So when they put those conditions, like all of the coefficients need to be integers, well, if they're not, when you get done with your first step, then you can turn them into integers or anything else they want by multiplying everything appropriately.
Okay.
Okay?
Yeah.
What else you got?
Okay, this one says factor the following polynomials,
Okay?
and then it gives us 3x to the 4th plus 5x cubed minus 7x squared minus 3x plus 2.
Okay, what do we need to use here? Can I, is there a greatest common factor?
No.
not a quadratic. It's not a quadratic in disguise. It is a quartic.
Okay.
The only way we can factor this is by applying the rational factor theorem. So what are our possible rational factors? Let's list them. This is also going to be a 20-minute problem, I should add, but maybe we'll get it done in 10.
Well, I thought
unless she wants you to do this on your calculator in the same way.
Yeah, he wants us to just graph it.
Okay.
I'll graph it on my calculator and I'll tell you the zeros.
Okay. And your calculator will give you precise numbers?
Yes.
While you're doing that, let me try to graph it again on Wolfram Alpha and see if it does it a little quicker this time.
One of the zeros for that problem is negative 2.41.
Hold on. Let me get it in here first.
Okay.
Yeah, whether or not you can use a calculator is extremely important on some of these. In other words, if you couldn't use a calculator, this is a rational factor problem. Notice what Wolfram Alpha tells you what to put in, gives you a close graph and a zoomed out graph. In other words, if we zoom out on that graph, about 100, we're looking at this. And then it also gives you the roots, minus 2/3, plus 1, minus 1 minus root 2, and root 2 minus 1. Now, you were giving me decimal answers. Does the Inspire give it to you more precisely, which is this way?
Yeah, I think so. Well, yeah, they give them to you like in decimals.
Well, that's not precise. In other words, there's no way you can give this answer in a decimal. Minus 1 minus root 2, or even root 2 minus 1. What is the decimal answer for that? It's rounded up, whatever it is. If you want to give an exact answer, you have to give it in radical form. Notice that we have 2 real solutions and 2 irrational solutions. They're real, but they're irrational. And irrational solutions always come in pairs. And notice that that is in pairs. In other words, if I have minus 1 plus root 2 as a solution, then I also have minus 1 minus root 2. It's like imaginary solutions. They always come in pairs. And notice that that is what we have here. This is minus 1 minus root 2. This is minus 1 plus root 2.
Oh, okay.
Okay? And we could do this manually. Our rational factor theorem was going to give us 2/3 as one of the possible solutions, and it was going to give us 1 as one of the possible solutions. And we would have tried each of those. They each would have worked. So we divided that quartic by each one and reduced it to a quadratic. well, to solve it, we're going to come up with all 4 of these solutions. So it wouldn't have been that hard to do because there weren't that many possible rational factors. In other words, how many rational factors do we have here? We have plus or minus 2 over 1 and plus or minus 2 over 3 and plus or minus 1 over 1. That's our only choices. Okay? And this one worked and this one worked. So we would have found out pretty quickly what our rational factors were. Then that would have left us a quadratic. Could have applied the quadratic and come up with these other 2 solutions.
Okay.
All right. What else you got?
Okay. It has another solving problem.
Okay.
So it's x to the 4th minus 5x squared minus 10x minus 6.
Another problem that we can't do unless we want to do it the long way. I thought it might be a quadratic in disguise. In other words, take away that, and it's really a quadratic. But the moment you put that x term in there, it's not a quadratic. You can't factor it within a normal way. I'd have to use the rational factor theorem or graph it. Obviously, they want you to graph these and figure out the zeros from your calculator.
Okay. Yeah.
This one wouldn't be that hard. Our possible answers would be this. But still, that's 8 possible rational factors. And we'd have to try each one to see whether it worked or not.
Yeah. I see.
Looks like most of tonight's session was graphing.
Yeah. Yeah. Well, I think that's probably it for the questions I have on homework.
Okay. That sounds good.
Yeah.
Ellen,
Okay.
I'll talk to you next time.
All right. Thank you.
You're welcome.